Okay, so today we're going to be talking about section 7.4. I'm going to split it up into two videos just because we'll probably end up splitting it up into 2 days, and that way you don't have a really long video to wade through, but you're welcome to go as far as you need to. Okay, so a sequence is a list of numbers in a particular order, and generally there's a pattern, okay? And so if you look at this first list of numbers here, you're like, can I tell what the pattern is? A lot of times you'll try to write an equation. There's 2 different kinds of equations you can write. One where you just say, well, all you do is just add 3 to each one, or all you do is just times by 5. And the other one is explicit, where you just say, well, if I want the 100th term, this is what I'm going to do. You plug in 100 into your formula and you'll get your answer. Okay, and so I think the big thing is, do you want to know what you do to get from one term to the next, or do you want to just say, you know what, if I want a specific term, I plug in that term number as n, and I can get specifically that number, so it's explicit. And so your list can have an infinitely many number of terms in it, because it could be ... forever, or it could just be like a specific list, finite. And so you'll be working with these over the next couple of years. So it could be infinite or finite. There you go. So finite would be just this list. And notice they put it inside of braces, okay? You'd be like, hey, look at those ones. And then infinite would be that ... Be like, keep using this pattern and you'll get to the rest of the ones. So one thing you may have seen in middle school, I mean, it just depends on your teacher. You might have seen arithmetic, you might have seen geometric, and you might have seen just kind of patterns in general, saying, can I come up with what the next one is? Because it's really good mathematics to practice noticing and working with patterns. Arithmetic means there's a specific difference, D, that's either added or subtracted from one term to the next. And that's the only thing that changes from one term to the next. And so if you look at these first, 3 sets of numbers, and you're like, okay, is there a specific value that's added or subtracted from each term? Then you'll know it's arithmetic, okay? And this one right here, if you just, and you can subtract one term, the second term minus the first term. So you could do 12 minus a negative 4 and get 16. 28 minus 12, you get 16. So you're adding 16 each time, except for this one, you're actually adding 14. So not arithmetic. This one, if you subtract sequential terms, you will notice that you're just adding 4 each time. So this would be yes, and it's arithmetic. And this one right here, you're like, I don't know what's going on. Okay, well, just minus them, okay? If you do -6 subtract 5, that's how you can figure out what changed, okay? Addition, subtraction. So take term 2, might subtract term 1, okay? And so put a subtraction sign between the 2 terms. So you got -6 and you got 5, you put a subtraction sign between it, you get -11. If you do -17 and then subtract a -6, you get actually -11 as well. Okay, so if you notice, you're decreasing by 11 each time. And so, yes, this is arithmetic. And the common difference is -11 because you're minus 11 from one term to the next. Now, one thing that we did in one of our books, it was like a book or 2 ago, we actually said, let's graph it. And if you graph arithmetic sequences, you will notice that they are linear, because in linear equations, you notice that there's a common difference or slope that gets you from one term to the next, okay, from one point to the next. There's always a consistent value that helps it change by. And so, if you graph it, again, how would you graph a list of numbers? There's no x, y, t. Well, you synthetically call term 1 the value 18. Term 2 will call the value, the output of 14. Term 3 is 10. So it would not make sense to connect these values because they're actually just discrete values. So term 1 is 18. Term 2 is 14, term 3 is 10, and notice if they have a common difference, well, then it's an arithmetic sequence, okay? And so just want you guys to see that connection to figure out the common difference. I said take the term after it, subtract off the term before it, and you can graph these values to see, is it linear? The graph of an arithmetic sequence lies on a straight line. it has a slope of D, the common difference, and N, the X value, is the term number. That's the independent variable. So it's just kind of interesting to see. You can watch, arithmetic sequences, as the term numbers increase or decrease by a common difference. Okay, so part two, or side two of this, is how could you write equations? And I start with, first of all, let's talk about some vocabulary. I think the big thing is, if you look at a list of numbers, okay, it's a sequence, and a sub 1 represents in the terms that you see the first term. Okay, 1 represents the term number, so the value of a sub 1 is 5. A sub 4 represents the fourth term, and that would be 11. So a sub 4 is 11. So I think just kind of knowing what do we mean when I say a sub 2, okay? And then let's think about this one here. Can you just come up with, because sometimes math is about, yes, learning formulas, yes, coming up with like, how do you solve it? But other times it's like, is there a logic you can see here? If you have $90 and every day that you work, you get additional $40, how much would you have after 5 days? And what would be your equation you would write? And so you start with $90 and you add $40 every single day that you work, okay? Okay, if you work for 45 days, not 5 days, 45 days, you would do 90, pardon me, I gotta get a pen to write with, 90 plus 40 times 45, and that would give us 1890 after that many days, okay? And there really isn't much more to it than that, okay? And then the next question says, if you have 24 sheep on day 1, and every day thereafter, you add 5 more. Okay, so you get 24. And every day that you wait, you get 5 more. Okay, so the next day you get, each day that you wait, you're going to get 5 more. When will you have, how many will you have on day 80? So here's the deal. Okay, let's think about this a second. If we do this formula on day 1, you're going to actually have 29 sheep, okay? And the thing is, no, you have 24 sheep on day 1. And every day after that, you're going to add 5 sheep. So we need to adjust our formula to fix this, okay? So this is going to be kind of foreshadowing to what we're going to be doing in these sequences, to be like, hey, the first term actually is 24. And so the thing is, you're going to add 5 every day thereafter. Okay, so if you plug in X as 1, on day 1, you actually have 24 sheep. If you plug in X as 2, like on day 2, you're going to have, 29 sheep. Okay, because 2 minus 1 is 1, and times 5 is 5, plus 24 is 29. So it's how many sheep you're going to have every day. So on day 1, you have 24. On day 2, you have 29 because you've added 5 sheep. The next day, if you plug in 3 for this function, or you just add 5, you're going to get and have 34. Okay, and so our formula works if X represents what day you're on. Okay, and so this is something we're going to use for our explicit formula. And I want us to look at this real quickly. We're going to talk about explicit, where you're like, hey, on day 82, how much will I have? Okay, explicit gets you straight to the point. Explicit in music, etc., is basically, yes, it has bad words in it, but what they're saying by that is you just go straight to the point without sugarcoating it, perhaps, is what they're saying. I can't speak for people, but I think the big thing here is you're not going to have to hem and haw and come up with every single term between term 1 and 100. You can go straight to term 100 and be done. And I think that's the expedited situation that they're speaking of in here. So you start with how many you have on day 1, and then you're going to add your D, your common difference. Okay. You're going to add 5 sheep or whatever it is. And you don't add it to the first day, you add it every day thereafter. So in your formula, you need n minus 1d. And so, you can see how this is going to work on this question right below. Okay, you've got an equation that says, okay, on day 1, I have 3 sheep. Okay, so a sub, the value of a specific term, if you want to get to like the 100th term or the whatever, n represents what term number you're talking about. You could make a note of that someplace if you want to. You start with term number 1, which is 3, and you add on to it. That common difference here is 4, okay? And you do it times n minus 1. Okay, so we've got n minus 1 times 4. Or you could write 4 times n minus 1. It doesn't matter. Okay, so you're going to add on 4 to every day after that first one. Okay, and so if you distribute it out, okay, you're going to get 3 plus 4n minus 4, or 3, okay, that'd be negative 1. Sorry, let me erase that. A little tired over here. And so we're going to do 4n minus 1. Okay, so the value of a specific term. So if you want to find like the value of, say, the 3rd term or the 4th term, let's do the 4th term. So a sub 4 is equal to 4 times 4 minus 1. So that would be 15. And if you look at this, you're like, hey, look, it does make sense. You're just adding 4 each time. Okay. And if you wanted to go explicitly straight to the 250th term, you would plug in n is 250, and you could get specifically and straightforwardly to that thing. Now, the other kind of formula is recursive. And so if you think about cursive letters, you know you're kind of always looping back before you move, as you move forward. And so it's like an L and, you know, some of those strange letters that you loop. So the value of recursive, you have to give them 2 facts. You have to just tell them where to start and then what to do to get to the next term. So the value of the first term, and then this next thing to be like, hey, to build the very next term. So let's talk about this. So if the very first term is equal to 3, so this, we're going to do a sub 1 is equal to 3. So start with 3 is what they're saying, okay? And then to get to the next term, okay, now how do you say to get to the next term? Okay, if you start with a specific term, okay, and then you add on 4, guess what you're going to get? The very next term. How do you denote the very next term after a sub n? You would do a sub n plus 1. Okay, it's really interesting to be like, start with a term, add 4, and you're going to get to not a sub n, you're going to get the a sub n plus 1 term, which would be the term after a sub n. Okay, it's kind of abstract to talk about, okay? There are a couple ways to say this, but this is the most basic one to say is start with a term, a sub n, and then add 4 to it, you get to the next term. Now, you may be saying, hey, Kinzer, you started with a sub n here. I thought a sub n was the term we're trying to find. A sub n just represents a term in general, whatever term you want to talk about. Okay, if that's the term you want to find, call it a sub n. Okay, plug in n to the right side of the equation, and you'll find that value of that term. If you start with a term, which is a specific term a sub n, you add 4 to it, you're going to get to the very next term after that. Because if this is an infinite sequence, you're going to have as many terms as you could possibly want to find, and any of them in general could be called a sub n at any point in time. Okay, so it's just kind of what you're talking about for this. Okay, so let's try to decipher what we have here. If a sub 1 is 5, that means start with 5. Okay, so put in the blank 5. Okay, and we're going to build the sequence. So if you start with a sub n and you add 3, you're going to get to the next term. So start with whatever term you want to and add 3, and you can get to the next term. So you would get 8, okay? And you're like, okay, well, let's add another term here. And so we would get 11. And then add 3, you get 14, etc. Okay, so that's a good question to be thinking about it. Okay, and if you want to say like, okay, well, I don't always love recursive. This is recursive that they gave us. Sometimes they'll say, can you put this into explicit? Because that's kind of boring. Like if I want the 100th term, I'm not about this. So let's practice doing this. The explicit formula for this very exact same thing, explicit, okay, would be to find the value of a specific term n. You would take the first term, which is 5. I'm looking at this formula right here. And I would do plus it to n minus 1 times d. Well, look, what's the common difference? Well, you can see it right here. The difference is you're adding 3 each time. And if you distribute this out, I'm going to write here a sub n is equal to, let's see, distribute this, you get 3n minus 3. So 5 minus 3 is going to be 2. So you're going to get 3n plus 2. Okay, so for this sequence on the right, you could use either formula to get you to the answers. And if I say, hey, you know, can you look at this sequence or look at this expression or this recursive formula? Can you write the explicit or vice versa? You can see that the rate of change is the slope, the coefficient of n. So notice 3n plus 2. Now notice, why don't we start with term 2? Well, it starts with 5. You're like, wait, that's because in graphing lines, we start at the y-intercept, okay? And then we go up. In these term thingies, okay, in these sequences, we don't start at term 0, we start at term 1. So term 1 is 5. Term 2 is 8. And so if we went backwards to the left to get term 0, we would notice that term 0 would be 2 if we follow that pattern. There is no term 0, but some people like to look at it, so they kind of link these concepts together in their brains. Okay, so with arithmetic sequences, we don't use a term 0, but term 1 is where we start. And we can think about term 0 if that helps us as we're writing our equations. Okay, write the first 4 terms of this arithmetic sequence. Okay, so let's do it. We want to start with, we can tell this is a sub 1 right here. Okay, so this is 4. And then can you tell from this sequence formula, this explicit sequence formula, that we could apply it, or you could say, you know what, I can tell that the slope, the rate of change is by 2. And so if you add 2 each time, you're going to get 6, and we're going to get 8, and we're going to get 10. Okay. So, you know, if you would like to evaluate it, or you would like to, if you'd like to evaluate, or you'd like to use it a different way, plug in n as 1 and plug in n as 2, plug in n as 3. I guess that would be the only way I would do it. You would get the same exact answers. Okay. If you plugged in n as 1, you would get 4 as your first term. If you plug in n as 2, 2 minus 1 is 1, times 2 is 2, plus 4 is 6. So you would get the exact same values. Okay. If you have this, will you write the explicit equation? What would be the value of a sub 50? Okay, because you can tell all you're doing is just adding 4 each time, but I'm not about to just add 4 50 times, you know, to get actually 49 times to get to that answer. So let's write the explicit equation. So the explicit equation says to get a sub n, a value of a specific term, you take the first term, which is 3, and you add on to it n minus 1 times the common difference, which is 4 in this case. Okay, let's distribute this out. And you get a sub n is equal to 3 plus 4n minus 4, or a sub n, oh, we did this before, didn't we, is equal to 4n minus 1. And if we want to find a sub 50, and technically you wouldn't have to reduce that. And what would we do? Plug in 4 times 50, and we'd minus 1. If you do 4 times 50, and you minus 1, you're going to get 4 times 20, 200 minus 1, 199. So you'd write a sub 50 is equal to 199. And I do want to see your left side. Don't just give me 199. Just like in functions, tell me what you did to get to that answer. Okay, write the explicit function for the sequence that you see and find the 20th term of that arithmetic sequence. Okay. So a sub n is equal to 13 plus, and then we do n minus 1, and then it looks like we are minusing 4 each time. So yes, the d value can be positive or it can be negative, okay? And the truth is this will work. We can also distribute this out, okay? And we can say 13 plus negative 4n plus 4, and so the value of a sub n is equal to negative 4n. And notice you can see the slope here is the rate of change. It's subtracting 4 each time, and then it's going to be plus 17. You're like, wait, we don't start with, I know that. The 0th term would be 17 if we figured it out. That'd be the y-intercept. But if n is 1, plugging it in here, you do get 13 for your answer. Okay, and so notice, check it. Plug in a sub 1. Okay, a sub 1 equals negative 4 times 1 plus 17. Yeah, you're going to get our first answer. Okay. All right, let's do a sub 20. And you do negative 4 times 20. It's negative 80, and add 17 to it. You're going to get negative 63. So these are arithmetic sequences, and our book assumes that you've already learned this, and you may or may not have. And our book jumps directly into geometric sequences, but I just feel like that's a little rude. Okay, and so I feel like having the background, you're going to do this next year in pre-calc, I feel like is real helpful to be able to say, I've seen this before. It's just linear. Okay. And so you'll see these equations. Geometric are you multiply by a certain factor between each one. And so to figure out what this is, you can take the second term over the first term and then reduce it. So the third term over the second term and reduce it, because that helps you figure out, hey, what do I times by to get from one to the next? So if you're like, what is this? Notice you're just timesing by 3. And so this would be yes, and then multiply by 3. Okay, so the common ratio. Okay, they call that for the ratio. And so notice if you put negative 18 divided by 6, you get negative 3, or 54 divided by negative 18, you get negative 3. So you just write a fraction out of the consecutive integers, and you can get those answers. This right here is not, because you times by 2 here, and you times by not 2 to get to there. So this would be no. This one is no. And this one is yes, and it is, let's see, negative 1/4. And you just can write the fraction of consecutive integers or divide it in your calculator, and you can get those values. Okay, so the following thing we're going to do is, well, can we write, not just recognize if they're geometric, can we write some equations about this? And now I may struggle with this skosh. Let me see if I can get zoomed in here a second. My last sheet of paper is over here. Come on. I have to work a little harder to get it. I'll pause the video. Okay, so what we're going to do is we're going to look at geometric sequences and see, can we write those equations? Can we see what is going on with them? And I think on this one here, it's asking us to determine if it's geometric, and then write the formula about it. Okay, and so if you kind of cheat and look ahead to the next side, you'll see the formula written there. Okay, for arithmetic or for geometric, and it's going to be the explicit one, but I'll write it right here on our side as well. So if you've got a formula, so a sub n equals, and I'm not sure why I'm using a highlighter, but let's make it nice. So a sub n is equal to, you do a sub 1, and then you do r, okay, the common ratio, to the n minus 1. Because if you think about it, term 1 is going to stay the value of a sub 1. Okay, and so if you plug in n as 1, the exponent becomes 1 minus 1, which is 0, and so you don't multiply it by the ratio for the very first term. Okay, a sub 1 stays the value of a sub 1. And so, but then with every sequential term number, you increase that value, or you multiply it by that ratio each time you want to move from the term to the next term. So that would be the explicit. And then this is for geometric. Okay. There's an explicit for arithmetic. That's that linear one where there's a common difference. That's on the previous page. This is going to be the recursive right here. Now, recursive, again, in order to make progress, you have to loop back and look at the previous ones. It's just like when you're drawing letters in cursive, you loop back a little bit. So for recursive, for geometric, okay, you're going to write down, give them this term to start with, okay, and then you're going to say to get to the next term, okay, you take a sub n and you times it by r, and then you get the a sub n plus 1 term. So you start with a sub n, times it by r, and you're going to get to the next term. And then you start with the next a sub n term, okay, whatever term you start with, and you times it by r, and you get to the very next term right here. So those are the two formulas. So on the recursive, you have to give them a starting point. You need a sub 1, and you say, okay, to generate the rest of the sequence, you start with a sub n, and you times it by r, and then you're going to get the very next term. So let's check to see, is there a common ratio? Yeah, this one is going to be r is equal to negative 4. So to write this, let's do explicit. It says a sub n equals 2, and then the common ratio is negative 4, and then you do to the n minus 1. If you want to check it, try n equals 1. And if n equals 1, you plug it in on the right-hand side, you're going to get the value of the first term. If you plug in n is 2, you're going to get the value of the second term. If you plug in n is 3, you're going to get the third term, and so on and so forth. This next one is not going to be recursive, or not going to be exponential. It's not going to be geometric because they don't have a common ratio. 40 over 60 is not the same, pardon me, as 20 over 40. Okay. And so visually, if you graph an arithmetic sequence, it makes a line. And to write the equation, you would do a sub n is equal to a sub 1, which is 4, plus, that should be a plus sign. Let me fix it. Plus n minus 1 times the common ratio, or the common difference. This is linear, so it has a common difference, okay, is going to be 4. And so if you distribute this out, you're going to get a sub n equals 4n plus 0. Notice the value of the first term is not 0, but if you did a 0th term, you would get 0 for your answer. Okay, and so working backwards, you'll notice the rate of change is that slope. Okay, and so it's okay to leave it like this. It's also okay to simplify it as well. Okay, to make it look like a linear equation. For exponential growth or geometric sequences, notice they have a common ratio, and this is doubling each time. So to write this one, we would do a sub n is equal to the first term, which is 2, and then you times it by r. The ratio is 2 to the n minus 1. They just reduced this to make it 2 to the n. And you may wonder why and how. If you just have 2, it's 2 to the first. If you combine the like terms in the exponents, because you can, okay? So you do 1 plus n minus 1, 1 plus, oh, highlighters, love it. 1 plus n minus 1. Combine like terms, 1 minus 1 is 0. This becomes this right here. So normally you don't do any sort of combining like exponents, etc. You just write the equation, be done. So for example, this one right here is a sub n is equal to 32. The common ratio is going to be 2 over 8 is 1/4. So it'd be 1/4 is right to the n minus 1. Okay, and so that's how you'd leave this one. Okay, if you wrote it as a recursive, you would say a sub 1 is equal to 32. A sub n plus 1. To get to the next term, you take a sub n and you times it by 1/4. Okay, so this is the recursive, and this is going to be the exponential, or the explicit formula for this term, or this sequence. And so you can graph it, be like, term 1 is 32, term 2 is 8, term 3 is 2. Actually, I need to go further than that. You're going to get a half. And so we're not going to connect them, but you can see that this does show exponential decay, and it's by 1/4 is the decay factor. Okay, and so, or the ratio. Okay, so let's see if we can knock into some of these questions right here. This one says, write the recursive equation of this geometric sequence. Okay, and so here we go. And the recursive equations right here. You start with the first term, and then you say to get to the next term, you take the previous term and you times it by r. So let's write the recursive equation for this. So a sub 1 equals the value of 4. Okay, and you start with a sub n, and it looks like you times it by 3. Okay, so you times it by 3, and that gives you the n plus 1 term. So to get to the next term, you take the previous term and you times by 3, and then that will give you that next term. So that would be the recursive one. Let's find the first 5 terms of this one. So it says the first term is 4, so start with 4. And then see if you can read this. It says to get to the next term, you do 2 times the value of any given term. So to get to the next term, you times it by 2, so you get 8, you get 16, you get 32, you get 64, etc. This one says the value of the first term is 100, and it says to get to the n plus 1 term, you take a tenth of the previous term. So that would be 1/10 of 100 is going to be 10, and a tenth of that is going to be 1, and a tenth of that is a tenth. And that would be 100th. So you're just timesing it by a tenth each time, okay? Write the first 5 terms of this recursive sequence. Start with -4, and it says to get to the next term, you take half of the previous term. So take it times a half, you get -2. Take it by a half, you get -1. Negative a half, and then you get -1/4. Okay, so just timesing each term by A half will get you from one term to the next. Write the recursive sequence. A sub n plus 1 to get to the very next term. You start with a sub n, and then you are going to, it looks like you times it by -3. And you could write it like a sub n plus 1 is equal to -3 times a sub n. But we forgot something. You got to tell people where to start. A sub 1 is equal to 2. And so you need this fact, and you need to say, all right, to get to the next term sequentially, you start with a given term a sub n, and you times it by -3. All right, here we go. So let's see if I can get to this last page here. We're only going to do half of it on this video, and the rest I'm going to do on the next video. Okay, here's the explicit formula. It tells what things are. To get to a value of a term, you take the value of the first term, and you times it by r to the n minus 1. Okay, so let's do it. So the explicit formula is a sub n is equal to the first term, which is 4. The common ratio is 3, and you raise it to the n minus 1. Why? Well, because the value for the first term, you look at the sequence. If you plug in n as 1, you want to multiply by 3 no times. Okay, you want to start with 4. Okay, and so for term 2, that's when it times just by 3. So every time after that, you times by 3. Okay. Write the explicit equation for this one. So a sub 1 equals 8 and r is 3. Okay, find a sub 6. So we have to write the explicit equation and then find what the value of a sub 6 is. So a sub n is equal to the value of the first term, which is 8, and the ratio is 3 into the n minus 1. So that's an explicit equation. And I said, okay, can you find a sub 6? So let's find a sub 6. The value of a sub 6 is going to be 8 times 3 to the 6 minus 1, or 5. Okay, so if we put that in our calculator, times it by 3 5 times, 8 times 3 to the 5th is going to give us a sub 6. And please tell me, don't just give me an answer. A sub 6 is equal to 1944. There you go. Okay, write the explicit equation for the nth term of each of these. So a sub n is equal to, explicit gets you straight to where you want to go. If you want the 1000th term, great. You can get there. You don't have to recursive and loop back and keep tracking forward term by term by term to get to those. That's what the recursive is about. A sub n is equal to the first term, and it looks like we are taking, that's a half. So if you don't know what the ratio is, take term 2 over term 1 and look at that fraction. Term 3 over term 2 and write that fraction. So it's a half to the n minus 1. This right here is a sub n is equal to 5, and then it looks like you're timesing by 2 each time to the n minus 1. Again, we need n minus 1 because every term we find is going to be multiplied by 2, with the exception of the first term stays 5. Okay, so a sub 1 is 81, so we're going to start with 81. A sub n equals this, and then the ratio, can you tell from here what the ratio is? It's a third. And then you just put n minus 1. So you can see in this recursive formula, you can tell what the ratio is as well. Okay, you just have to kind of know how to rate it. A sub 8 is 5, and then the ratio is a half. So to write the a sub n equation, you need the beginning value. We need a sub 1, but I don't know a sub 1, so we're going to have to find that. We know the ratio is a half, and we know it's going to be the n minus 1. So let's do a little math to figure out what a sub 1 is going to be. Okay, so what we got to do is kind of use that exact same formula with everything we know and say, well, let's try it for the given data of a sub 8. Okay, so once upon a time, a sub 8 was equal to 5. Okay, so the value of a sub 8 is 5. So in place of that, so a sub 8 is equal to the beginning value times a half, 8 minus 1 times. So we know the value of a sub 8 is 5. So we're going to put 5 here. So 5 equals a sub 1 times a half to the 7th. And if we want to get a sub 1 by itself, notice a sub 1 and a half to the 7th are related by multiplication. So if we do 5, oops, my pen is not working. 5 over a half to the 7, we're going to get a sub 1's value. Okay, and so we're solving this equation on the left. So if you find that quotient, the answer to that is 640. So instead of a sub 1, we're going to put 640, and that's our new formula. A sub n is equal to 640, a half to the n minus 1. So let's see, how did we do that? They told us the formula, the ratio, okay, and they told us once upon a time I did a sub 8 and I got 5. Well, a sub 8 equals a sub 1 times a half to the 8 minus 1. Well, a sub 8 actually is 5. If you want to solve it for a sub 1, we just have to find the quotient, because a sub 1 times a half of 7, or half to the 7th, is going to give us a sub 1. Okay, let's try this next one, see if we can actually do the same thing. We want to write the equation. So a sub n is equal to the value of a sub 1. We don't know it. And it's times the ratio. The ratio is -2 to the n minus 1. We really need a sub 1. Okay, so we have to play this game of they gave us a term, and using the rate in that term, we can actually solve the equation for a sub 1. So a sub 6, okay, is 48. Okay, and so a sub 6, the value of a sub 6 is equal to a sub 1 times r, which is -2, to the 6 minus 1. Again, we know a sub 6 is actually 48. So 48 equals a sub 1 times -2 to the 5th. To solve this equation for a sub 1, we're going to divide both sides by -2 to the 5th. If you put that in your calculator, you're going to get a sub 1 is equal to a delightful, don't know what it is, let me look and see if I can find it, -3/2. Oh, it's so cute. -3/2. So our formula is a sub n equals -3/2, awesome, times -2 to the n minus 1. It's a little tricky. You might want to practice this on your homework. Okay. We're going to do these last two questions, and then I'm going to save the geometric means for the next video. Here we go. Rewrite this explicit sequence into recursive form. Okay, so if this is explicit, we can tell that this right here is a sub 1. We can tell this is r. And so the thing is that we know a sub 1 is equal to -3. We also have to say a sub n plus 1 equals the value of a sub n, and you times it by the ratio. Okay, times by 4. That's it. Okay, so to get to the next term, if you know the first term is -3, what are you going to do? You're going to start with the value of any term, and you're going to times it by 4, and that will give you the very next term. Okay. All right, let's try working the other way. Write this into explicit form. Okay, again, we're talking about geometric. And so your homework is going to be about geometric, but I just wanted to give you the background of arithmetic. So here we go. A sub 1 is 27. So a sub n equals a sub 1, which is 27, times r. Can you tell, like, this is r? 2/3. And then n minus 1. There you go. Explicit formula ready to go. All right, well, thank you. Have a good day.